Hello all and welcome to Rust for C Engineers series. Today we are starting with chapter 2, that is variables and arithmetic expressions. So it's a very interesting chapter and we are going to discuss lot of design differences and also syntax differences. Both of this will be covered. And the content of the entire series is based out of a book called Rust for C Engineers and the link is in the description box. Let's get started. So the syntax, let x colon I32 equal to 32 basically declares a variable named x and of type signed 32-bit integer and assigned a value 32. Okay, so is this only an assignment? No, this is called a binding. The let keyword binds x to 32. So what is binding? We are going to see that shortly after this program. So there is a difference between variable declaration in C versus a variable binding in Rust. Okay, the second one is the value is being printed and a format placeholder is used here. Okay, so the opening and the closing brace is a format placeholder in Rust. Okay, unlike C uses something like a format specifier like %d, %f, %c, %s, right? So here that's called a format specifier and this is called a format placeholder. So we are going to discuss this as well shortly. And the third thing we have to discuss is I32, right? So in case of Rust, all the data types are very specific. Okay, so in case of C, what happens? We have data types like int, long, and they all change based on the size changes based on the target platform. So if it is a 64-bit integer, 64-bit platform, target platform, the int size can be different. The same thing on a 32-bit platform, the int size can be different. But in case of Rust, I32 basically means it's a signed 32-bit integer on all target platforms. So it makes it explicit and it helps in portability. Okay, it helps in portability. And it removes ambiguity, right? So when you're changing code from one platform to another platform, then this will be very useful. That is the third difference. So these are all design differences. One is a binding, another is a format placeholder, and third things, the data types are very explicit and very precise and clear. Okay, now let us execute this program first. So for compilation, we are still using Rust compiler directly because for now we don't want a project structure. We are focused more on the Rust concepts. So variable 32 is printed. The second one is variable binding. So here this part is Rust and this part is C. Excuse me. So in case of C, int x equal to 32, basically there is a variable name x and it points to a memory and the memory contains value 32. So similarly, same thing here as well. Identifier or variable x, okay, has value 32 in a memory. So these two are same. But apart from this, there is binding. So binding means compiler rules. Okay, so the variable x, apart from just pointing to a raw memory which is and has a value, physical memory having a value, it's also bound by compiler rules. Okay, so these two are basically like roommates. Okay, they don't have any rules and regulations, but in this case what happens? They are bound by compiler rules. For example, this is like, a wedding. Two people are in a marriage and they are bound by legal rules, right? Marriage legal rules. Same way, there are some rules that this X needs to follow when it's bound to value. So what are the rules? All the rules will cover in chapter 4, specifically designed for this. However, few rules we'll discuss in this video. So for now, only remember that binding means compiler rules. Okay, apart from pointing to physical memory, apart from being assigned to a physical memory having a value, it's also bound by compiler rules. The next one is variable naming. So all the variables names should follow coding convention. Okay, so it's a snake case coding convention. So which means what? A Rust identifier may start only with a lowercase letter or an underscore. So if there are multiple words, they can be separated by an underscore. So if you do not follow this, unlike C, it can give a compiler error. Okay, and no special characters, no capital letter, and no spaces. So, and also if possible, choose a meaningful name. Okay, so this is the second thing, naming conventions. Let's run this. Yeah, all the values are printed, variable names and values. Okay, so the next one we'll see is variable placeholders, right? Placeholders were used for printing. Okay, so here, so if you see, there are 3 variable bindings. One is age. The variable age points to an integer. Variable pi points to a floating point, and variable active points to a boolean. So here, before we move to format holders, just notice one more thing, that explicitly there is no type given, like I32 is not given. So this is not required. So by default, Rust can infer types. So this can be explicit type can be omitted. So for beginners, so since you are writing programs, if you are beginners, please go ahead and explicitly start doing those, so that it becomes a part of muscle memory. And once you're comfortable, you can start omitting writing types here. That is one thing. And second thing is that, see, all these 3 types are different, right? One is integer, another is floating point, and then a boolean. But if you observe, the same format placeholder is used here. The same format placeholder is used for integers, then for floating points, and also boolean. And apart from this, if there were string variables or any other user defined types, we could still have used the same thing. Okay, so it works for most of the types. So this is one of the design differences between Rust and C. This has made using printing simplified. It has simplified the printing. It basically allows the system to select the formatting type, because it infers type already. So the compiler already knows the type, right? So this is printing becomes easier. The next one. So the next one is, see, there are 2 ways of printing. So either the variable names can be printed just like C after the format specifier and variable name. So another way of printing is include all the variables within the format placeholder. Okay. So if you include them, you can print it. So both are same. They'll give the same result. So let's just print it. The same two blocks, whether outside or inside, prints the same thing. The next one,